Modern U.S. destroyers are among the Navy's most capable surface combatants. Depending on the particular flight and configuration, an Arleigh Burke-class ship can displace roughly 8,000 to more than 9,000 tons at full load. Yet, even this enormous ship still needs to anchor while waiting outside a harbor, conducting certain operations, riding out delays, or remaining safely in position without constantly using propulsion. Anchoring is not simply the act of dropping a heavy object into the sea. It is a coordinated evolution involving the bridge, the navigation team, engineering personnel, and sailors working around some of the most powerful deck machinery aboard the ship. And once the anchor disappears beneath the surface, the crew must trust an invisible system of steel, friction, geometry, and seabed resistance to keep the entire destroyer from drifting into danger. A ship has no parking brake. When its propellers stop turning, it does not remain fixed in place. Wind pushes against the superstructure, current presses against the underwater hull, waves repeatedly lift and shift thousands of tons of steel. Even a light wind can slowly move a destroyer. In stronger conditions, the ship can drift surprisingly quickly. The crew could keep using the engines to maintain position, and modern ships can maneuver with great precision. But continuously operating propulsion is not always practical. It consumes fuel, requires machinery and personnel, and may be unnecessary when the ship needs to remain in one location for hours. Anchoring gives the destroyer a fixed connection to the seabed, but the captain cannot simply choose any point on the chart. The anchorage must have sufficient depth, suitable bottom material, enough room for the ship to swing with changing wind or tide, and safe separation from land, navigation hazards, and other vessels. The navigation team calculates the planned position before the evolution begins. They examine water depth, weather, current, seabed information, and the amount of chain expected to be used. Then the ship approaches slowly. Unlike docking, where lines connect the vessel directly to a pier, an anchored destroyer will continue moving around its anchor as conditions change. This creates what sailors call a swinging circle. Every ship inside an anchorage needs enough space to rotate without colliding with another vessel or drifting into shallow water. So before the anchor ever moves, the crew must already know where the destroyer will probably travel throughout the night, and that is only the beginning. Most people imagine that an anchor holds a ship because it is extremely heavy. Weight helps, but that is not the main principle. Modern naval vessels commonly use stockless anchors. Unlike the classic anchor seen on tattoos with a long crossbar near the top, a stockless anchor is shaped so it can fit closely against the ship's hull and pass through the hawse pipe. The anchor has a long central shank and broad flukes near its lower end. When it reaches the seabed and the ship begins pulling away, those flukes rotate toward the bottom. If the seabed is suitable, they dig into mud, sand, or clay. The anchor is therefore not acting like a dumbbell tied to the ship. It is acting more like an enormous buried hook. As the horizontal load increases, the flukes can dig more deeply, increasing their resistance. But the type of bottom matters enormously. Soft mud may allow the anchor to penetrate deeply, but may not always provide the same resistance as firmer material. Sand can offer excellent holding conditions. Clay may hold strongly, but can make breaking the anchor free more difficult. Rocky, heavily obstructed, or uneven seabeds create different problems. The anchor may fail to bury properly, or it may become caught. This is why charts describe the character of the bottom in designated anchorages. The crew is not merely asking, how deep is the water? They are also asking, what exactly are we dropping this anchor into? But even the best anchor cannot work properly without the most underestimated part of the entire system, the chain. The anchor chain is not simply a rope made from steel. It is a major structural component of the anchoring system. Each link must withstand enormous forces as the destroyer pulls against wind and current. Naval anchor chains commonly use studded links, with a metal brace across the middle of each link. The stud helps maintain the link's shape and reduces the tendency of the chain to twist or deform under load. The chain passes from the anchor through the hawse pipe, across the windlass machinery, and down into a chain locker deep inside the forward part of the ship. And the chain itself contributes greatly to the ship's holding ability. When sufficient chain lies between the ship and the anchor, it forms a sagging curve called a catenary. This curve acts like a massive shock absorber. When a wave or gust pushes the destroyer backward, the ship must first lift and straighten part of the heavy chain before transmitting the full load to the anchor. That softens sudden forces. More importantly, the chain helps keep the pull on the anchor closer to horizontal. That matters because anchors hold best when they are pulled sideways across the seabed. If the ship pulls sharply upward, the force can lift the flukes and break the anchor loose. This is why sailors talk about scope, the relationship between the length of chain paid out and the water depth. The exact amount depends on the ship, weather, bottom conditions, available swinging room, and commanding officer's judgment. More chain generally creates a flatter angle and better holding power, but it also creates a larger swinging circle. Too little chains can reduce holding ability. Too much can bring the ship dangerously close to another vessel as it swings. So the chain is not simply let out until it looks right. Every length is measured and reported. Traditional naval terminology divides anchor chains into sections called shots. Markings allow sailors to identify how much the chain has gone overboard as it passes through the machinery. In darkness, spray, and noise, those markings give the team a vital answer: how much steel is now between the destroyer and the bottom. At the center of the anchor station is the windlass. U.S. Navy seamanship training material describes the windlass as machinery installed primarily for handling and securing the anchor and anchor chain. Most are positioned near the bow to work the ship's forward or bower anchors. One of the windlass's most recognizable components is the wildcat. This is not a simple drum. It is a specially shaped wheel with pockets that engage the links of the anchor chain. As the wildcat rotates, it hauls the chain aboard or controls its movement through the system. A brake applies friction to control the chain. Chain stoppers and other securing devices prevent the anchor's load from resting solely on the windlass when the system is secured. During preparation, sailors inspect the equipment, remove required securing arrangements, verify communications, and ensure the anchor is ready for use. The bridge and forecastle must remain in constant contact. The commanding officer controls the ship. The anchor detail controls the equipment. Between them, every order must be clearly heard, repeated, and confirmed. When the anchor is released, gravity takes over. The chain may begin paying out rapidly as the anchor falls. This is where the operation becomes visually dramatic and physically dangerous. The brake operator must control the speed. Too much braking can interrupt the anchor's descent or create severe loads. Too little can allow the chain to run dangerously fast. Friction can generate heat. Moving chains creates crushing hazards. Loose clothing, tools, or hands cannot be allowed near rotating equipment, and no sailor should be casually stepping across the path of a chain capable of restraining an 8,000 or 9,000 ton ship. The anchor station may look like open deck space. During the evolution, it became an industrial danger zone. The crew does not necessarily see the anchor reach the seabed. They feel and interpret what the chain is doing. Reports from the forecastle tell the bridge how the chain is leading, forward, aft, to port, to starboard, or nearly vertical. The angle and tension provide clues about the anchor's behavior beneath the water. Once the anchor reaches bottom, The destroyer continues moving slowly away while additional chain is paid out. At first, the anchor may simply lie on the seabed. Then, the chain begins pulling along the bottom. The flukes rotate, they bite. The anchor begins to bury. As the ship falls back, tension increases. The chain may rise from the water, then relax as the ship moves forward again. The crew watches for signs that the anchor has set. Navigation personnel simultaneously monitor the ship's position using visual bearings, GPS, radar, depth information, and the planned anchorage limits. If the anchor is holding, the destroyer settles into its expected swinging pattern. If it is not, the ship may continue moving. That is known as dragging anchor. Dragging can happen because the bottom is unsuitable, the anchor failed to dig in, too little chain was used, weather conditions increased, or the anchor was disturbed after setting. And on a crowded night anchorage, dragging anchor is not a small inconvenience. It can become a collision emergency. Once anchored, the operation is not over. The ship maintains an anchor watch. The crew repeatedly checks position, weather, water depth, nearby vessels, and the condition of the anchor system. The destroyer should remain within its expected swinging circle. Its heading may change, sometimes dramatically, as wind and current shift. That movement is normal. What is not normal is a steady progression beyond the permitted boundary. Navigation teams use several methods to detect dragging. They can monitor GPS position, take bearings to fixed landmarks, compare radar ranges, and observe how the chain is leading. An anchor alarm may provide an additional warning, but professional watchstanding cannot rely on one electronic alert. If the ship begins dragging, the crew must respond quickly. The bridge may start engines. Additional chains may be paid out if there is safe room. The anchor may need to be recovered and reset. In an emergency, the ship may have to leave the anchorage entirely. Navy safety guidance emphasizes that when a vessel is anchored, nothing should interfere with the readiness to run, slip, or heave in the chain, or to use the spare anchor. That requirement reveals something important. An anchored destroyer is not simply parked. It remains prepared to move. Because weather can change, another ship can drag toward it, or an operational order can arrive with almost no warning. Anchoring becomes far more difficult when the wind increases. A modern destroyer presents a large surface to the wind. Its superstructure, mast, sensors, and hull act like a sail. As the wind pushes the ship backward, the load travels from the hull into the chain, then into the anchor and seabed. The forces do not remain constant. They surge. The bow may rise on a wave, pull against the chain, then fall back. A gust can suddenly increase the load. If the chain's catenary begins straightening, more of that force reaches the anchor directly. The ship can use additional scope when conditions and swinging room permit. It can place propulsion on immediate standby. The command can also decide that remaining at anchor is becoming more dangerous than proceeding to sea. That decision may sound strange. Wouldn't the open ocean be worse during severe weather? Not always. Inside a confined harbor, a dragging destroyer can collide with another ship, strike a pier, or run aground. At sea, the vessel may have far more room to maneuver under its own power. The anchor is powerful, but it is not magical. It has limits. Good seamanship means understanding those limits before they are exceeded. Dropping the anchor uses gravity. Recovering it requires machinery to reverse the entire process. When the destroyer prepares to depart, sailors return to the forecastle and the windlass begins hauling chain back aboard. But the windlass is not meant to drag the ship across the entire anchorage by brute force. The bridge maneuvers the destroyer toward the anchor, reducing the horizontal load while the chain is recovered. Reports continue as the chain comes in. The lead changes. The amount remaining outside decreases. When the chain is nearly vertical, Sailors report that it is up and down. At this point, the anchor may still be buried. Breaking it free can require the ship's movement and the upward pull of the chain. Then comes the moment the anchor leaves the bottom, but even then, the crew is not finished. The anchor can return coated in mud, clay, marine growth, or debris. Water may be used to wash the chain and anchor as they come aboard, preventing large amounts of seabed material from entering the hawse pipe and chain locker. The team must also watch for a fouled anchor. Cable, fishing gear, old chain, or other debris can become wrapped around it. In some cases, the anchor itself may not sit correctly against the hull when recovered. Only after it is properly housed, secured, and inspected can the anchor detail stand down. The ship may be underway, but the anchor must still be ready for the next emergency. A guided missile destroyer may be designed to fight aircraft, missiles, submarines, and enemy ships, but some of its most dangerous work happens before a single weapon is fired. It happens on the forecastle, where sailors stand beside moving steel and wait for an order from the bridge. The anchor falls, the chain runs, the flukes bury themselves beyond sight, and slowly, an 8,000 or 9,000-ton destroyer stops moving. Not because the anchor is heavier than the ship, not because the chain is unbreakable, but because every part of the system works together: the seabed, the flukes, the catenary, the windlass, the brake, the navigation team, and the sailors controlling it all. The destroyer may carry some of the most sophisticated technology ever sent to sea. Yet, when it needs to hold its ground, it still trusts an idea sailors have relied upon for thousands of years: a piece of steel, a length of chain, and a crew disciplined enough to control both. Because sometimes the oldest system on a modern warship is also the one preventing thousands of tons of steel from drifting into disaster. Do you think anchoring is the most underestimated operation aboard a destroyer? Let us know in the comments, and subscribe for more hidden engineering inside the world's most powerful warships.